So today in this video we are here with some technical questions that comes in category 1. Basically in category 1 I have kept some HR question that we will discuss in some another video, and in this video we are going to talk about some technical question that can be asked in any interview related to electronics and electrical engineering. These are all the technical uh, interview, and these are the basic questions that can be asked in any interview. So the first question is like, difference between active and passive components. What do you understand by the active components and passive components? Basically, active components are those components that can supply energy or it can amplify energy, and also it control the current flow. Like in transistor, it is used as amplifier. Diode, we can control the current and it amplifies the current, right? So these kind of components are called active components. Now what are passive components? Passive components can only consume, store and dissipate energy. Like register, it will dissipate energy. Capacitor is used to store charge, so it will store the energy. And inductor, yes, inductor is also used to store the energy. Now, the next question is, what is Ohm's law? We know that Ohm's law is given by V is equal to IR. So, Ohm's law states that the voltage is directly proportional to current at a constant temperature, and it fails to explain about the non-linear device and non-ohmic device like diode, transistor and vacuum tubes. Ohm's law is not applicable for these device, like some device that is non-linear, like in diode we get the non-linear graph, and non-ohmic device that do not follow the Ohm's law. And these are the devices like diode, transistor, and vacuum tubes. They do not follow Ohm's law. Now, in diode, basically we use silicon and germanium. So, for silicon diode, the knee voltage is 0.7 volt, and for germanium, the knee voltage is 0.3 volt. What is knee voltage? Knee voltage is that threshold voltage after which the diode start to give there is the exponential rise in the current. Okay, there is the exponential rise in the current flow. So that is the knee voltage. After this voltage, you'll get the exponential rise in the current. Now the next one is, what is PN junction? We know about PN junction. What is PN junction? When the P-type semiconductor, like when the P-type semiconductor and the N-type semiconductor are joined together, here is the transition layer formed, that is abrupt, and this transition layer is basically of immobile ions from P side and from N side. So this junction is called PN junction. What is next question is, what is Zener breakdown? So it occurs in heavily doped diode like Zener diode and Zener diode. Zener diode is it works in reverse bias. Okay, so it occurs in heavily doped diode under high reverse voltage, and when we are applying very high reverse voltage, so what is happening, a very strong electric field is generated, and that actually ruptures the covalent bond. And when the covalent bond is ruptures, this gives the sharp rise in the current and maintaining the constant voltage. At the constant voltage, we get the sharp rise. There is the sharp rise in the current. So this is Zener breakdown. So whenever we read about Zener breakdown, there is one more term called that comes into light, that is avalanche breakdown. One thing we should get to know that Jenner breakdown is useful. Avalanche breakdown uh, means it can be it destroy it, it is dangerous for the component. So Jenner breakdown, let us know distinguish between these two breakdown, Jenner breakdown and avalanche breakdown. So what is Jenner breakdown? So basically, for the if we see about the primary mechanism, Jenner breakdown has high electric cause. It is due to high electric cause, and this causes the quantum tunneling. And in avalanche, collision of the charged carrier take place. Okay, so this is called impact ionization. In Jenner breakdown, the and the diode is heavily doped PN junction, and in avalanche the diode is lightly doped. In Jenner breakdown, the depletion layer is very narrow. In avalanche breakdown, depletion layer is relatively wider than Jenner. The um, the breakdown occurs uh, generally the breakdowns occur at the lower voltage, that is below 5 volt, and the breakdown occurs at the higher voltage, that is above 5 volt. In Jenner breakdown, the negative breakdown, the temperature coefficient is negative for the Jenner breakdown. Like, breakdown voltage decreases as the temperature increases, and for avalanche breakdown it has positive temperature coefficient, that is breakdown voltage increases with the increasing temperature. Now, if you see on the basis of reversibility, Jenner breakdown is reversible and it does not damage the junction. On the other hand, avalanche breakdown is irreversible and it can damage the junction if not limited. Okay. The next question that can be asked is, what are the three terminals of BJT? BJT means bipolar junction transistor. Bipolar means two poles are responsible, like electrons and holes. Okay. And junction, there are the junctions. Okay. There are two junctions in BJT, and transistor. Transistor is the device that is used as the amplifier or sometime as the switch. Okay. And yes, it can be used as the it can also be used as attenuator. So the three terminals of BJT are emitter, that is represented as E, base represented as B, collector represented as C. In Among these, emitter is highly doped. If we talk about the doping, so doping on the basis of doping, the emitter is highly doped, then collector, then base. If we talk about area, okay, whose area is more, then collector has more area, then emitter, and then base has very less area, it is narrow, very narrow. What is the difference between BJT and FET? So BJT is a current control voltage source. Okay, current control, and it is bipolar device, and where it uses both electrons and holes. While on the other hand, FET, that is field effect transistor, is a voltage control voltage source, and it is unipolar device, means only the majority carriers are responsible for the flow of the current. Now if asked what is the full form of MOSFET, so MOSFET means the full form is metal oxide semiconductor field effect transistor. Metal oxide semiconductor field effect transistor. Now what is the full form of JFET? junction field effect transistor. What is the difference between NPN and PNP? NPN transistor and PNP transistor. In NPN, P type is the base. Okay, P type is the base. The middle letter that is written, it is the base. And it is sandwiched between 2 N type. And here the majority charge carriers are electrons, and conduction primarily via electrons. Means majority charge carrier is electron here. What is PNP? In PNP, N is the base and N is sandwiched between two p-type semiconductor. In PNP, conduction is primarily via holes, and holes are the majority charge carrier moving through N-type base, and N is the base. Next question that can be asked in any interview is, what is IC? What do you understand by IC? A tiny a tiny semiconductor, a tiny semiconductor wafer containing thousands or millions of fabricated resistor, capacitor, and transistor acting as a complete functional circuit are IC. See, in IC we see like all our computers, mobile phones, almost every gadget it is made with IC, and it has lot of components. It is a tiny semiconductor wafer, and it contains thousands and millions of resistors, capacitor, transistor, and they all make one chip to complete some functional circuit. The purpose is to make some functional circuit. The next question can be, IC 555. What is the use of IC 555 timer? So IC 555 timer can be used for generating accurate time delay. Since it is the multi-vibrator IC 555 timer, it is the name is of this IC is IC 555 timer, and it is also the multi vibrator. So this generate accurate time delay, and in oscillation and pulse with modulation signal. It is used in oscillators, in PWM modulation as well. In IC triple five timer, what is pin 3? From pin 3 we take output, and from pin 1 it is the ground. Let us see the diagram. Yes, this is the IC triple five timer. It has 8 pins. You can see 1, 2, 3, 4, and below here 5, 6, 7, 8. 1 is ground, 2 is trigger, 3 is output. See, from pin 3 we take output. 4 is for reset, 5 control voltage, 8 threshold, 7 discharge NPN transistor, and 8 is supply. Next question that can be asked is, what is operational amplifier? So in short we also say op amp, op and amplifier amp amp. So op amp. So a high gain electronic DC voltage amplifier with differential input are operational amplifier. See, it is actually, the name already says it is the amplifier. So it is the from op-amp we get very high voltage amplifier. It is used as the high voltage amplifier, DC high voltage amplifier, and it has differential input. Means differential input means differential amplifier is there, two inputs are there, and from there the difference is taken, okay, and then it is amplified. So IC 741 is the most common example for the operational amplifier. let us see the block diagram of op-amp. As we see that it has differential amplifier, differential input. So this is non-inverting. Non-inverting input means positive input. Inverting inputs means negative input. So these two are fed into the input stage. So in this input stage we have differential amplifier, means dual inputs, means we have two input here. Balanced output means if there are two inputs then two outputs are there, so balanced output. And in input stage we use differential amplifier. It take the difference of the two inputs and after that it amplifies it. The second one is the intermediate stage. In intermediate stage there is dual input and unbalanced output, means two inputs are there and only one output, so this is unbalanced output. This is also differential amplifier, means it takes the difference and after that it amplifies it. Number three is level shifting stage. Level shifting stage, this is the amplifier. In level shifting stage, it is the emitter follower is used generally using constant current source. The next one is output stage. That is complementary symmetry and push pull amplifier is used in this output stage and then our output is got. So normally DIP 741 IC 8 pin is used as the common amplifier. DIP means dual inline package or packaging system. Dual means from this side and this side. Okay, and this is dual inline packaging system and it has 741 IC has 8 pins, 1 2 3 4 5 6 7 8. Let us see the each pin carefully. One is offset null. Offset null should be maintained at 0. Okay, and then number two is inverting amplifier. Inverting means inverting inputs. Inverting input means negative input. um, Non-inverting amplifier, the positive input here minus VCC is maintained here, minus VSS. Offset 5 point pin 5 is offset null, means this has to be maintained at 0. Number 6 is output, and number 7 VCC plus VCC, and number 8 is left with no connection, that is used for future use. Okay, future use. So if we try to draw one op amp, so this will look like this here, and output here. Inverting means negative, non-inverting means positive. So this looks like this. Let me make with sketch so that you will be able to see properly. It is like this. Input, these are input, right? And here 6 is the output, negative and positive. Negative means inverting input, positive means non-inverting input. And from here like plus VCC, and from here minus VCC is maintained. So this is the inside structure, internal structure of op amp. Now next question that can be asked in any interview is, what is the function of the rectifier? Why do we use rectifier? So rectifier is used to convert alternating current, that is AC, into pulsating DC, not DC. Okay, there will be ripples. So for smoothing the ripples we use filter and voltage regulator, then we get DC, pure DC. So rectifier, what it does, it converts AC into pulsating DC. In half wave rectifier, how many diodes are used? One. In center tape rectifier, how many diodes are used? Two. In breeze rectifier, how many diodes are used? Four. So these are important. They can be asked in the exam. Okay. Now tell me, what is ripple factor? Very easy. Ripples means, ripple. What do you understand by ripples? Ripple, we talk when we talk about the rectifier. Okay. So rectifier converts AC into pulsating DC. So pulsating DC means there are some part of the AC is also present in the DC. That some part of AC that is present in the DC, those are called ripples. Actually, we don't want ripples, right? So some part of AC that present on the DC is the ripple. So ripple factor can be said as the ratio of RMS value of AC component to the DC component in the output of the rectifier is called AC. Is called ripple. What ripple factor measures? So it measures the output purity. How pure is the output? It measures the output purity. There is one term called FF, that is form factor. So form factor is given as IRMS by IDC, and ripple factor is given as under root IRMS by IDC square minus 1. This is nothing but form factor. So ripple factor we can write as form factor square minus 1. This is the ripple factor. It is very important. Now, next question that can be asked in any exam is, why do we use filter circuit after a rectifier? Very easy. After rectifier we get pulsating DC that is not smooth. So to smooth out the residual AC ripple, to smooth out the residual AC ripples from the pulsating DC output, creating a steady flat and DC voltage, we use filter. What is LED? LED stand for light emitting diode, and it is a specialized PN junction diode that emits incoherent light via electroluminescence when forward biased. Okay, LED is also like it is a diode, and it is forward bias, means positive P side is connected to the positive terminal and N side to the negative terminal, then it is forward bias. When it is forward bias, it emits light. Okay, incoherent means it is not coherent, means the intensity is low, and the intensity is low and it is wide, not in only single direction. Okay, so that is called incoherent. And yes, electroluminescence means with the emission of the electron, it emits the light, that is called electroluminescence. Now, next question that can be asked in any exam is, why do we always connect a resistor in series with a LED? My god, in LED, that is silicon LED or GAS, okay, diode. So basically diode, they have very less knee voltage, and if you are not connecting any resistor in series with LED, then it will damage LED. Okay, it will damage LED. So we are actually using resistor to limit the current. to limit the current flowing through the LED, preventing it from overheating and burning. Uh, to prevent from any damage and to control the current flowing through the LED, we use register in series with LED. Next question that can be asked in any exam is, how do you decode register values using color band? Very easy. In color band, we use in register there are various types of colors, color band used to specify its resistance value. So for that, the color coding is used to find the value of resistance. And there is a mnemonics called BB BB Roy of Great Britain had a very good wife, and these BB Roy, uh, these represent the color, various bands. Okay, so bands represent digit, multiplier, and tolerance. Excuse me. Now, the next question that can be asked in any exam is, what is capacitor? So capacitor is a passive device. Okay, capacitor is a passive device and a component that store electrical energy in any electrostatic field is the capacitor. Capacitance is given as QYV, QYV, and it indicates the ability, how much charge per unit voltage can be stored in any capacitor. Next question that can be asked is, distinguish between electrolytic capacitor, ceramic capacitor. Hmm. So in electrolytic capacitor, the electrolyte used, that is the dielectric used, is the electrolyte, that is metal oxide layer. It can be aluminum or tantalum. And in ceramic capacitor, uh, the dielectric is made with ceramic material, that is barium titanate. Barium titanate. In electrolytic capacitor, the polarity, on the basis of polarity, polarized. Electrolytic capacitor is polarized. Means, what do you understand by polarized? That is, the positive should be connected to the positive, negative should be connected to the negative. But on the other hand, ceramic capacitor are non-polarized, and it can be connected in either direction. You can connect it in any direction, doesn't matter. And in electrolytic capacitor, its capacitance value is high, typically from few micro to milli millifarad range. Free mu microfarad microfarad to millifarad. And in ceramic capacitor, the capacitance is low, that is typically from picofarad to microfarad range. Electrolytic capacitor are generally larger and these are in cylindrical shape, while ceramic capacitor are smaller, often discs or rectangular shape. One example is MLCC. What is the frequency range of electrolytic capacitor? It is used for low frequency. And ceramic capacitor is used for, it is excellent for high frequency application. Typical uses are filtering, power supply, filtering, energy store, and in ceramic there are noise decoupling, coupling, filtering as high speed. The next question that can be asked in any exam is, what is transformer? So transformer is actually it is a static device that transfers electrical energy between circuit through electromagnetic induction, that is by altering AC voltage. It cannot function as a steady DC. Now next one is, what is SCR? SCR stand for silicon control rectifier. SCR is also called PNPN diode with gate, okay. A PNPN diode means p type to p type semiconductor to n type semiconductor. So there are the layers of p and p, means four layers are there, and three terminals and three junction, PNN1, NNP1, and PNN1, means total three junction are made. Okay, so we can understand it from here also, like if it is P N P N, okay, so like this. So how many junction? One, two, three. Three junction. It is a unidirectional device. It is used as a DC switch, and gate of SCR is made up of P-type semiconductor. Here it is P-type semiconductor. This is used as gate. P-type semiconductor gate of the SCR is um, made with P-type semiconductor material, and SCR is operated under forward bias. It is operated under forward bias. Now, distinguish between, what is the difference between analog signal and digital signal? So, what is analog? Analog signals are those signals that are continuous and it has smooth sine wave. On the other hand, digital signals are those signals, those are discrete, and and the square rectangular waves are digital signal. Okay. Now, analog signal. Analog signal represent values as a continuous range. On the other hand, a digital signal is represented by the binary zeros and one. Now here it is, analog and digital. In terms of precision, analog, that is, it's subject to noise and degradation. Since it is continuous and natural, so it has lot of noise and degradation is there. On the other hand, digital, it has high immunity noise, and it can easily be regenerated. According to analog signal, according to the data storage in analog signal, the to store the data and to retrieve it perfectly, it is little harder. But on the digital, we can easy to store and process the computer. Bandwidth, analog consumes less bandwidth. On the other hand, digital, it requires most of the bandwidth for same data. Example like human voice, vinyl record, mercury thermometer. These are the example of analog signals. And in digital signals like computer data, CD, digital watches, these are all digital signal. So I hope you enjoy this video, friends. Thank you so much for being with me. And if you like the video, please let me know. Thank you. Thank you so much. Take care and take care of your health. And see you later. Thank you so much.